So that there are two things. One is called a center of the gravity. Another one is known as center of mass. In IGCSE O levels, when you learn this concept about center of the gravity or center of the mass, you consider both of them as same. But in reality, center of the gravity is different from center of the mass. The concept is different. Basically, if we have an object which is a uniform object, like having a equal distribution of the particles, and I say that weight of this object is equals to 30 newtons. So if this object is having a weight of 30 newtons, so it will experience a gravitational force or a gravitational pull of 30 newtons. And the point where this object will experience that gravitational pull, the point where whole weight of an object appear to act, or where the whole objects, the point where the object experience the gravitational pull, that point is known as center of gravity. And what about the concept of center of the mass? Basically, it's a mean point or an average point where around which the mass is distributed, like because the object consists of particles. So if it is a uniform object, the mass is evenly distributed around that point. So the point around which the mass is evenly distributed, that point is known as center of the mass. So center of the mass is reference to the position, the location around which the mass is evenly distributed, where center of the gravity is actually a point where the weight of an object act or the object experience the gravitational pull from the planet. So when we explain the gravitation center of the gravitational force from the earth act on every point of an object, but we often draw a weight of an object acting at a single point. So this point, which is a mean location of the gravitational force, that point is known as center of the gravity. And what is the meaning of center of the mass? Center of mass is a point at which all the object mass are considered to concentrate, or this point is a mean location or average location of all the mass of an object. So the term center of mass is often interchangeable with center of the gravity for a uniform object. So if the object is uniform, we can say the center of the gravity and center of mass is same. But if object is non-uniform, then the center of the gravity and center of mass will not be same. Is it clear? The idea of center of the gravity and the center of mass. Any doubt in this? So the point where the weight of an object acts, that's called center of gravity, and the point around which the mass is evenly distributed, that is known as center of the mass. Then what is a free body force diagram? A free body force diagram represent or show all the forces acting on the object, and the length of the arrow shows the size of the force. Like if I draw a shorter length, it means that the value is small. And if I draw a longer arrow of a longer length, means a line of a longer length, it means the value is big. So the length of the arrow represents the size of the force, and the arrow is there representing the direction in which the force is acting. So example, you have an object which is on the inclined surface. So when an object is there on inclined surface, the surface is making certain angle with x-axis, and we place the object on the surface, and the question is show the free body or draw the free body force diagram for this object. So how we represent the free body force diagram? Free body force diagram represent all the forces acting on the object. So first thing, the weight of the object will be there acting downward. Then there is a normal contact force, because when two surfaces are in contact, they exert force, a normal contact force which is perpendicular to the surface, that is acting upward. And naturally this object tend to slide down. So when it tend to slide down the slope or move down the slope, so there is a friction between the surface, the inclined surface, and the object that resists this downward motion. So friction will be there. You can draw here between the two surfaces, or you can draw on the object just to show the direction. Both ways are acceptable. So that's the normal contact force, you can represent by R. Weight is there acting downward, and the friction is there which is opposing the motion. Is it clear, this concept of a free body force diagram? In this example, the object is on the inclined surface, a surface which is making certain angle. But it can be, an object can be on the horizontal surface, so if the object is there on the horizontal surface and it is stationary at rest, so object is not moving in this example, so weight of the object will act downward and the normal contact force, the force from the surface, will act upward. This is in a case when object is stationary or object is at rest. But we may have a condition in which the object might accelerate. So example, this object is accelerating towards right hand side. So if it is accelerating towards right hand side, means the force on which is acting towards the right hand side is bigger. So how to represent the two forces which have difference in the magnitude? So the force of the engine or force, the driving force denoted by F. Then there will be a friction which try to resist, but the friction is not equal to the driving force. That's why we are using a shorter line. The normal contact force, the force from the surface, is acting upward and the weight is acting downward. This is in the case when this object is accelerating towards right hand side. If it was decelerating, then the friction will be higher. If it is moving with a constant speed, then there should be no resultant force. So the driving force balances with a frictional force. So we should be able to use the concept of a terminal velocity and the Newton laws, relate the Newton laws. So what is the statement of Newton's first law? Newton's first law states, if the resultant force on the object is zero, if there is no resultant force acting on the object, so two possibilities are there. If it's a stationary object, if object is at rest, it will remain at rest. Or if it's a moving object, if object is moving, it will continue to move with a constant speed. So according to first law, which is also known as law of inertia, state that object does not change or resist the change in the state. So here is an object which is placed on the surface and initially object is at rest. So if initially object is at rest, if I apply two forces, 10 Newton towards right hand side and 10 Newton towards left hand side, what is the resultant force? And how to represent this resultant force? Sigma. This is a Greek alphabet sigma, and F, which means the resultant force. So 10 Newton towards right and 10 Newton towards left. What is the resultant force on x-axis? The resultant force, 10 Newton force acting towards right and 10 Newton force is acting towards left. So what is the resultant force here? The resultant force will be 0 Newton. So according to Newton's first law, if the resultant force is 0, an object is originally at rest, so what will happen? It will remain at rest. So object does not move, or object will remain at rest when the resultant force is 0. Same way, if an object is a moving object, so this object is a moving object and it was moving with a speed of 5 meter per second. Now what happened? The two forces are acting, but the forces are balanced forces. Force of 50 Newton on the right and 50 Newton on the left. So if the forces are balanced, resultant force is 0 on a moving object. So what happened? This object will continue to move with a constant speed. So it will continue to move with the same speed of 5 meter per second until unless unbalanced force act on this object. So Newton's first law states if the resultant force of the object is 0, it will stay at rest or it will remain at rest, or if it's a moving object, it will move at a constant velocity. And this first law is also known as the law of inertia. Inertia means the property of an object to resist the change in state. The definition of inertia, the property of an object to resist the change in state, and that inertia is directly proportional to mass. So if it's heavy object, it will be difficult to change the state of a heavy object as compared to lighter objects. So we can say the greater the mass, greater the inertia. So you have two objects. One is 5 kg. Both are at rest. Another one is 5 kg. Another one is 50 kilogram. Both objects are at rest or both are stationary. Which object will be difficult to move? A 5 kg, B 50 kg. Which object will be difficult to move? So B will be difficult to move, so we can say B is having a greater inertia. A is having a smaller inertia. So inertia is the property of an object to resist the change in state. That's Newton's first law. Then what about Newton's second law? Newton's second law states that if there is a resultant force act on the object will change its state, or greater the resultant force, greater the acceleration. So resultant force and acceleration are directly proportional. And the condition here, if the mass is kept constant. So we have two objects, two identical objects. Objects have the same mass of 2 kg, experiencing the forces of 100 Newton and 98 Newton, and the other one at 2 kilogram is experiencing a force of 10 Newton and 3 Newton. Which object will have a greater acceleration? Which object will have a greater change in speed? A or B? A is experiencing force on the right hand side is 100, force on the left hand side is 92. B is having force on the right hand side 10 and force on the left hand side only 3. Which object will have a greater acceleration? A or B? So for this, we have to find the resultant force. When we calculate the resultant force on A, that is 100 minus 98, so the 2 Newton towards right hand side. But for B, it is 10 minus 3, which is equals to 7 Newton. So B is experiencing a greater resultant force. And according to Newton's second law, that whenever there is a resultant force, there is an acceleration, and result acceleration is directly proportional to the resultant force. So one which experiences greater resultant force will have a greater acceleration. So acceleration of a B will be higher than A. And how we can calculate that? We use resultant force. This is a symbol like sigma F means the resultant force is equals to ma. So if we know the resultant force, if we know the mass, we can find acceleration. So the first example, because resultant force divided by mass is equals to acceleration. So resultant force is 2 and the mass is also 2. So acceleration is equals to 1 meter per second square. For the second example, resultant force divided by mass is equals to acceleration. Resultant force is 7 and mass is 2. So 7 divided by 2, that's equal to 3.5 meter per second square. So object 2 or B will experience greater resultant force, so it will show a greater change in speed. And the condition here that the mass must be constant when we are finding a relation between force and acceleration. And what about the relation between mass and acceleration? So for that purpose, we have to keep resultant force constant. So we know resultant force is equals to ma, or resultant force divided by m is equals to a. So resultant force must be kept constant. So if we have two objects of different masses, and this relation shows that resultant mass and acceleration are inversely proportional, lighter object will show a greater change in speed. So if we have 2 kilogram object and a 20 kilogram object experiencing a resultant force towards right hand side, same resultant force of 10 Newton, a resultant force of 10 Newton. So which object will have a greater acceleration we can identify, because mass and acceleration are inversely proportional, the resultant force is same, and we can calculate this acceleration. Resultant force divided by mass is acceleration, resultant force is 10, mass is 2, so acceleration of object A is 5 meter per second square. What about object B? The resultant force is still 10 and the mass is higher. It is 10 divided by 20, which is equals to 0.5 meter per second square. So lighter objects will have a greater acceleration than heavy objects if they experience the same resultant forces. So this is Newton's second law. And what about Newton's third law? And before the Newton third law, some examples related to the topic. Like in this question, a driver is starting his car, which is having a mass of 1000 kilogram. When the traffic light changes from red to green, when the driving force is 500 Newton, the car is still at rest. Car is not moving. Find the frictional force at that time. So because the car remain at rest, so it means that if an object does not experience the resultant force or resultant force is zero, it means the driving force balances with the frictional force. So if the driving force is 500 Newton, what about the frictional force? Because the resultant force is zero as the car does not change the state. So it means the driving force minus the friction force will be equal to 0. So driving force is 500 minus friction force is 0, or we can say friction force will also be equal to 500. That's why for A the answer will be 500. The second part, when the driving force increased to 6000 Newton, the speed of the car increases from 0 to 10 meter per second in 2 seconds. What is the frictional force during this process? So how we can work out the frictional force? First we write the statement here that the driving force minus the friction force is equals to resultant force. So we can say resultant force is equals to driving minus friction. As the object is moving, so driving force is higher than the friction. And according to Newton's second law, that resultant force is equals to ma. So driving force minus friction force must equal to ma. So we can write here like this formula: resultant force is ma and resultant force is driving minus friction. So we can say driving minus friction is equals to ma. The driving force is 6,000 according to the question. F is unknown. M is the mass of the car, which is 1000. And what about acceleration of the car? We can find its acceleration because the speed changes from 0 to 10 in 2 seconds. So acceleration is change in velocity. 10 minus 0 divided by 2. That's equal to 5 meter per second square. This will be square. So it will be 5 here. So 5 multiplied by 1000, that's 5000. And 5000 will be subtracted from 6000. So the friction force will be 1000 newtons. Is it clear, this example? Yeah, is it clear, this example about how we relate the resultant force with the friction and the driving? Then different scenarios in which we write the equation. For example, force on the inclined surface. So if we say this object is stationary or this object is at rest, on the inclined surface, so when object is at rest on inclined surface, how we can find its acceleration on inclined surface? So we have to resolve the weight first into component. Like here is an object which is on the inclined surface. So weight of this object is acting downward. The normal contact force is acting upward, perpendicular to the surface. Not exactly upward, but 90 degree to the surface. This object naturally tend to move downward, slide downward. So friction resists its motion, so friction is opposing the motion. So what are the forces acting? The weight is there, normal contact force is there, and a friction. Then what we do, we will always resolve the weight into its component. Like example, it is making angle theta here. So what we do, we'll always consider the axis. So the angle which the inclined surface is making means the angle of the inclined surface is always same as the angle of the weight. So these two angles will always be same. So we have weight will have two component. One of the component of a weight which is with an angle, that is called W cos theta. And the component of the weight which is against the angle, that will be equal to W sine theta. So always remember the component of the weight which is perpendicular to, this is a for perpendicular, the component of weight which is perpendicular to the surface on inclined surface, that is always W cos theta, and component of the weight which is parallel to the surface, that is equals to W sine theta. Now if this object is stationary, if we consider the first case, if this object is at rest, so when object is at rest, there is no resultant force, or resultant force will be 0. So if the resultant force is 0, so we can say R is acting perpendicular upward to the surface and W cos theta is acting down. So we can say R is equals to W cos theta, and W sine theta is moving from making the object slide down, and friction is upward. So we can say friction is equals to W sine theta. This is if the object is at rest. Is it clear, this part? First part, if we consider that this object is at rest, then there will be no resultant force, or the forces will be balanced, or I can write like R minus W cos theta will be 0, and friction minus W sine theta will be 0. Is it clear, this part? Then normally what happens, the object might slide down, the object might accelerate. So if the object accelerate down, in that case the resultant force is not 0, the resultant force will be equal to ma. But the object slide down on the surface, so the first equation will not change, R and W cos theta, because it is not accelerating in that plane. So R and W cos theta will remain same. But what about the friction and W sine theta? In that case we can say that W sine theta, because it is moving downward, so in that case the W sine theta will be higher, minus friction is equals to ma. And if we consider, so this will be the equation when it is sliding down. And if we consider friction is very small, so if friction is very small, we can neglect this friction approximately 0. So we can say W sine theta is equals to ma, and W is equals to mg, weight is equals to mass into gravity. So mass into gravity, sine theta is equals to ma, m will cancel with m. So A is equals to g sine theta. That will be the formula of acceleration on inclined surface when we consider friction is negligible. If friction is not negligible, you will use this formula. If friction is negligible and they ask to get the acceleration on inclined surface, in that case A will be equal to g sine theta. Is it clear, this part? When the so two conditions are there. First one, the object might be stationary on the inclined surface. The second condition, the object might accelerate downward, and accelerating downward having two cases, that it might have no friction. In that case acceleration will be equal to g sine theta. But if it is, the friction is having a considerable value, then W sine theta minus ma is equals to W sine theta minus f is equals to ma. Is it clear, this concept on inclined surface about the resultant force? So this is when there is no friction, and this is when there is a friction. Then when object is attached by a wire or a rope or a string, we call that force as a tension. So different scenarios are there. Like in the first example, one object is attached by a wire or a string, and this object is at rest. So if this object is at rest, what about the resultant force? So we can say resultant force will be equal to 0, because object is at rest, we'll apply the Newton's first law. So the weight of the object is acting down and the tension is acting up. So we can say weight minus tension or tension minus weight is equals to 0. Same way, if two objects are there attached by a string or a wire and both objects are stationary, so how we write the equation for this? So for rope 1, which is T1, balances the 2 kilogram mass only, like this is actually T1. So in this case, when we consider only this part, the weight is acting downward and T1 is acting upward. So we can say that T1 minus the weight is equals to 0 because it is at rest. So resultant will be 0. So T1 minus weight is mg. So mass is 2 and gravity is 9.81. That's 0, or we'll multiply, we'll get tension in the first rope as 19. Basically this is 1 and this other one is 2. So this T1 will come out as 19.6. But what about the second rope for T2? So T2 is holding both of the masses because T2, there is a weight of object 8 kilogram and there is a weight of object 2 kilograms. So both of their weights are acting downward and T2 is balancing that. So we can say T2 minus W1 plus W2 is equals to 0. So tension in the second rope T2 is equals to T2 minus W1. The first weight it will be 8 into 9.81 and the second weight it is 2 into 9.81 and that is equals to 0, and when we solve we'll get that as 98.1 Newton. Is it clear, the second example? And in terms of example, this is a 1 and this one is 2. Is it clear? This example, when two objects are attached with a string, a wire, and we want to find the tension in the rope. So the first object, because the first tension T1 is only for weight of the first object. But for the second tension, because it is keeping both weights, balancing both weights, so it will be W1 plus W2. And because the result is 0, it is not accelerating, so that's why the resultant force is 0. And if we have an object, another example, like two trolleys are there attached by a string or a wire, the direction of the force, the direction of the tension is always in the direction to pull. So if object is moving, the direction of, like example, if I say this is M1 and other one is M2, so for M1 it is forward, but for M2 it is backward, but both values will be same. So if we need the total driving force, the force which is driving or the resultant force, and the masses are given, like example, if I say the total mass is 1000, one of them is having a mass of 200, another one is having a mass of 800. So what we can do, or how we can solve this, first we can find the total driving force, the total force which is driving or resultant force, that is equals to ma. So mass is 1000, the total mass, because we are finding the total driving force. Friction is not neglect, friction is basically neglected here, it's not shown. So if there was a friction, then it will, the total resultant force will be driving minus the friction will be the resultant. So in this case friction is neglected. So if we want the total driving force or basically the resulting force, which is ma, so m is the total mass 1000 and acceleration of this object is 5. So the total driving force is 5000 Newton. So total the force which is driving this system, that is 5000. But if they ask what is the tension in the rope, so how we can find the tension? So because the whole system, like if the whole system is having acceleration of 5 meter per second square, so both trolleys will also have the same acceleration of 5 meter per second square. Acceleration of the trolleys will be same as acceleration of the whole object. Like if you are inside the car and your car is having acceleration of 10 meter per second square, so you are inside the car, what is your acceleration? Your acceleration will also be 10 meter per second square. So when we have the acceleration, because acceleration of whole object is same as acceleration of individual object, which make the system, the whole system expression is same as expression of individual object which combine to make the system. So we can find this tension. Friction is not given. So for if I consider this object 1 which is having a mass of 200 kg, so tension is at there, so T is there, there is no friction, and because it is accelerating, so its resulting force, as we know, whenever object accelerates, resulting force is equals to ma. So here the resulting force is T, so we can say T is equals to ma. So T is equals to m, mass is 200 and acceleration is 5. So 200 multiplied by 5, that's equal to 1000 Newton. So force on this object will be equal to 1000 Newton. Is it clear? So the idea that objects will have same acceleration in the system as individual objects. Then it can be like two objects can be attached by a pulley. If one is at moving downward, other one is moving upward. So because acceleration is there, so resulting force will be equal to ma. So for m2 weight is more. So we can say w2, instead of writing m2g, we can write w2 minus. So if we are working out the acceleration of the whole system, this is basically, they consider, if we consider this alone object, it depends on which one we are finding for. If we consider this alone object, so here resultant force will be equal to ma. So it's w2 is acting downward, t is acting upward, so we can say w2 minus t is equals to m2a. And if we are talking about for first object which is accelerating upward, so for that one t minus w1 is equals to m1a. And if we want the acceleration, so we can add the two equation. When we add the two equation, so this t will cancel with t, so it will be w2 minus w1 is equals to m1 plus m2a. So this is the final equation which we have. Is it clear, this example? Is it clear, this example? And same way, if the object is on inclined surface, we can also use that. If object is accelerating downward, we can use this equation that the resulting force is equals to ma. So here weight is acting downward, this T is a tension. So accelerating force for W, the total mass M1 and M2. So that is equals to M2G, M1 plus M2A, because the total mass of a system is M1 plus M2. So this was about the resultant forces related to Newton's second law. Any question related to the class today? Tomorrow we'll do more examples related to this resultant force from Newton's second law, like example of elevator, and then we'll do Newton's third law and discuss the past paper questions.